Okay, let's pick up where we left off. So what I want to do first, carrying on from the previous one, just want to show you the velocity. Now the diagonal velocity is slightly less than the x and the y. Just to prove that, although we can kind of see it, we can just prove this out. So string of the velocity. And all we need to do here, self.player .vel should round out to 2 decimal places. And then that's another part of our list. So each item in our list for the debugger. And then if we go to game and run this, we should get here, velocity 0, 0. So we've got 60, minus 60 in the x-axis. It should go minus 60 if we go up. Yeah. And it accelerates to it very quickly because that's how I've set it up. But you can change your force variables and your friction variables and maximum speed variables in the player class to change this. And then if we go diagonal, it normalizes so it's slightly less. So we've got a good realistic movement here. What's that? Don't like that big long word. So we'll put it back to velocity. And let's pick up where we left off. So this time we're going to go through animations. There's a couple of little functions I want to add, helper functions, which we're going to put into the game class here. What I'd like to do first, because it's an ARPG, we need a cursor for the mouse. And we don't want the horrible standard arrow cursor. So let's make a function for it, and then we can put it into the draw class, and we can draw the cursor. So we'll call this custom cursor. And we'll pass the screen in here, because we're going to put it into the draw method. So I want to set the standard mouse visibility to false. And then the cursor image will be equal to, so this is the first time we're going to see loading of an image, and this is how you do it in Python, and then you just pass the path through to it. So I open my file explorer here. We'll go into here, tutorial. We've got an assets folder, spun, and I want to get myself a custom image of my cursor. So I'm going to have a little square white target. So let me go and get that image. My assets folder, I'm just going to put it here. So we only need one. That's my cursor image. There it is, super tiny. A few pixels wide. So that's going to be in the same directory as the game, which I'm working in at the moment. So, and it's in the assets folder. So here, all we need to do is assets, cursor.png. Alpha, then cursor rectangle. Every image needs a rectangle to move around. So we can go cursor image dot get frect. Center is equal to Pygame mouse dot get pos. Then we need to, let's try the fblip from Pygame CE. So we're going to pass the image and then at the position. So right. Center. I think that should work. So if we go down here, let's close off these input events. Well running. Let's put that in here. Let's have custom cursor dot draw. Actually, we'll need it after, so it's displaying on top of everything. So I want this to happen from the very off. Self.screen. Let's see if that works. Object has no attribute draw. Of course it doesn't, because we're not drawing it. We're just running it as the function itself, of course. So no attribute fblip. I can't remember what it is. Let's just for now. There we go. I've got a cursor. It's moving around. I want to give it a little bit of transparency. I don't want it fully white. So what we can do, just before we put it to the screen, cursor image dot set alpha. So this is happening every frame. Remember these things. So cursor image set alpha, and I'm just going to change it to 150. So 0 would be not visible, 255 would be fully white. So let's try that. See, name cursor image is not defined. Obviously, because I've put it in the render text, not in the custom cursor. It needs to be here. There we go. It's got a slight transparency to it. Quite like that. So let's start animating the character. So we need a couple more functions in here. Let's close these down. A couple more helper functions. So first I want to get images. So this will loop through a folder and it will get all the images from that folder. So we're going to put a path into this, and that will output all the images into that folder path. And then I want to get animations. So this will loop through a folder. That folder will have a bunch of other folders that have the animation states in them as their names. And then they will have the images inside those folders. So when we get to our character state machine, it will just call on those folders. So we want to call all the animation states in that folder. So same again, we're going to put a path into there, path to the folder where all the animation folders are. So let's start with this one. Animations equal to a dictionary. So it's going to be a dictionary where the key is the folder name or animation state, and that's going to be equal to a empty list. So this is going to loop through all the folder names, all the states, all the animation states, and return an empty list for each one. So we can import this into our character classes. So for OS, this is how you would edit a dictionary. You just update and put the new dictionary key value items you want in here. So file name. So for each file name in the path that we're putting in the directory, the key is file name, and then it's an empty list. So we should get a dictionary full of all the animation states in that folder and an empty list as the value for each of them. So we just return this. Return animations. And that's it for that. That's all we need. So we can close that off. Don't need that now. Get images. So we're going to have an empty list of our images. We need to return all the surfaces from that folder, image surface, same thing. So it's for the file in OS list directory. Path, same again. So full path is equal to os path.join path and file. So the path we've passed in, and we're going to join the file for every folder, every item in that path. So we've got the full path of the folder and then that file on the end of it. So that should give us the string of the full path. Then our image can be just like we did earlier. The full path, that's the string, just like we did for the cursor. Convert alpha, which makes it more efficient, apparently. And then images.append image. So that's just going to add that image into the images empty list that we had at the start. Run through each folder, and then we need to return images. And that's all we need for that. Fantastic. And then we can go into our character class and start using them. So we don't need this anymore. We don't need to fill the image. The image won't be a surface anymore, just a rectangle. So we need to import some images. So first, I want to set myself a frame index. So that's the frame, the animation frame we're going to be on, which is 0. So this is can count through them, and we're going to call the relevant picture in as the game is running. Relevant frame, and then I want a function called import the images. So images to put a path in here. So self.animations. So we're going to call this in here. So self.import images. And we're going to put the path here, which we'll leave just as path for now. Let's put the path in now. So the path is going to be assets, because that's the folder in the same direction. And then in that assets, I've got a folder called characters. And I want the relevant character. So in our NPC class, we've got a parameter called name, self.name, which is here. We can just put that into here. And that is the path that we need. But here it's still part of the string. But there's a cool thing in Python. If we just wrap this in curly brackets, and then put an F at the start, it will recognize that as the variable as a different data type within the string. And it will convert it to the string. So that's our import images. Let's finish it off. So that's going to initialize the class and import the images here. So it's going to give us a self.animations. It's going to be equal to our function. So self.animations, a function that we just made in the game class called get, what did we call it? Get animations. So we've got game here, self.game.get animations. And remember, we needed to put a path in here, and this was the path. So obviously we're passing it through here. So we could just pass it through as path from here. And then for each animation in the self.animations.keys, so each of the animation state names that we've got, the full path is equal to the path we've passed in plus animation. So character plus the animation state. So like I said, got a folder and it will have idle, run, jump, fall, etc. That would be this. So then self.animations. So that's got all our empty lists. Animation. So self.animations dictionary. The animation key is equal to our other helper function from self.game, which is self.getImages. Self.getImages. And that will just append all the images as a list for each animation state. And we just pass the full path in here. Fantastic. So in here, our cursor, and we've got our text. If you remember up here, we should have a folder called characters. So let's get that now. I'm going to paste that in. Somewhere I've had before. Then in the characters, we should have a list of characters, and we've got the player. So as we know from here, we've passed the name, the string player name, to our player instance. So when the player is called, we've got characters, player, and that's the images and the folders it's looking for. And this is going to import all the images for each animation state just by doing this function. And that will work for all the characters. And you can put whatever animation state names you would like into that folder, and it will just import them and initialize them. So it doesn't have to do it at runtime. Well, as it updates, not necessarily runtime, but as it's updating, it doesn't have to do this function all the time. Because I've heard it's an expensive operation to be importing the images. So in our player, we should have some states. Ooh, so this is what I've done earlier. So these are going to be strings. So we're going to have left, right, up and down animations. Attack down, attack left, attack right, attack up. So if we click in there, we should have the frames. Each frame for the animation, and they're numbered 0 onwards for however many there are. So if you remember, so we've got the characters player, the name of the animation state, and then we just need the PNG file, which will be the number. And we've got this frame index, right? So let's use this. Let's create an animate function. And then we can pass this animate function into the update method, and the player should animate. So I'm going to make this quite flexible. So first we need to pass in the relevant state to that animation. So when we call the animation, we know what folder, we know what we're going to use, what animation state we're going to use. We can pass that in. We want a frames per second variable, so we can change that, we'll pass that parameter in when we call animate. And do I want it to loop, or do I want it to finish on the final frame? So standard loop will equal true. So if you leave this final parameter out of the animate call, then it will just loop back round to 0. So let's write it. So firstly, self.frameIndex obviously started at 0. And if we're going to put this in the update function, it's going to run every frame. So we're going to do self.frameIndex plus the self.frameIndex plus FBS. So that will just add this on every time and increment whatever we pass in here. So now that index is incrementing. Every time it turns to 1, 2, 3, etc., we want to get that frame. So firstly, we want to check if it's more than equal to the length of the self.animations state minus 1, because it starts at 0. And then if loop is true, just if loop, I like to do, self.frameIndex reverts back to 0. Otherwise, self.frameIndex is equal to the very last frame, which is this. In terms of number, so that will return the integer, the length of the self.animation state. So however many is in there, minus 1, which will give you that final frame number, and it will stay on that final frame if not loop. And then we need to just create our image. So the self.image then will be just be self.animations state at the integer self.frameIndex. So integer means if it's 1.2, 1.5, 1.6, it will just return 1 here. So we keep it as an integer, so it's always that. So it always kind of rounds down in Python if you call something an integer. If it's 1.9, it won't return 2, it will return 1. And then that should be all we need, I think. So we do need to change this. We don't want it to initialize as Pygame surface. So we want to initialize it. Say let's go with idle to begin with. So we take our self.animations dictionary and we take the list of, say, idle down, which was one of my states, and that's the key. And obviously this a list as the value. So we go at position of self.frame index, which is obviously initialized as 0. So it will get the idle down animations 0 and 0 image, and then convert alpha. So that'll set the initial frame. And then of course we just want to update. So let's do the animations first. Do them after actually. So let's do something just to let's just call it first. So self.animate idle. Let's say idle to the right. And if you remember, we've got the state, which is this. So idle right is the state. The FPS, so the frames per second. Remember, we need to times this by dt. So we've got dt here. So I can go 15 times dt. So that should give me 15 times per second. If I do 30, it'll be 30 times a second. If I do 1, it will be every second. So dt is equal basically a second. So let's go with 15. So it happens like 4 times a second. 15 times a second, sorry. So, and then was there anything else? To pass through loop equals true. So let's keep it as loop for now. And then obviously the player has its own update method. So we want to put this into there too. So animate. So let's see if that works. Okay. We didn't import OS. So to run through the files, Pygame just needs OS importing operating system. And there we are. We've got an animating character. Move him around. So let's see how flexible that those animation functions are. So when he's going slow enough, he'll return to idle. When he's speeding up, we'll make him run. So what I actually want to do later, which in another video, we'll go through a state machine, where we'll create a new class for idle, run, attack, fall, and it'll have its own update feature and its own logic for inputs to change the state. So it will be a lot more code to write, but it's so much easier to handle and debug because it will be just like the game states. It will switch between different animations and different states, and you can get it to do different things in each state. So, for example, if you don't call movement in the state, it won't move until the state is finished, and you can add a timer into the state. So there's lots, it's very flexible, and we'll go through that later. But for now, let's just prove what this can do. So we'll just do it for the player for now. So if the velocity magnitude is less than 1, so in any direction, if that velocity becomes less than 1, we'd like it to do that idle animation, which would be nice. Just that. Otherwise, let's do the run animation. Change that to run. So now we can run that. And he's idling. And when we move, he's running until that velocity gets down to less than 1. Okay, that's it for animation. The next video, we'll go on to world building. So we will create the world, and we'll use a software called Tiled, and we'll do the state machine later once we've done the world and the camera and moving around. Okay, see you next time. Thank you very much.